Have you ever looked up at the night sky, past the streetlights and the haze of the city, and just wondered, why? Not just why the stars are there, but why is there even a there for them to be in? Why does space exist? It's a question that sounds incredibly simple, yet it's one of the most profound inquiries we can make. It's the ultimate cosmic question that has haunted philosophers, poets, scientists. It's the kind of question that makes you feel small but in a good way. It connects you to the grand, unfolding story of the universe. We often take the vast, dark expanse for granted, like the air we breathe. But what if there was nothing? No distance between Earth and the Moon, no void for galaxies to spin in. The very fact that we can ask this question is a testament to the magnificent stage on which our existence plays out. The curiosity it sparks is fundamental to being human. A child might ask, why is the sky blue? But the question, why is there a sky at all, is a step into a much larger arena of thought. This isn't just about the absence of stuff, it's about the presence of a framework that allows for stuff to exist and to be separate. Think about it. Without space, everything would be crammed into an infinitely dense, singular point. There would be no here and no there, no journey, no exploration, no room to even exist. The existence of space is the primary condition for everything else we know and observe. It's the canvas upon which the masterpiece of the cosmos is painted. Understanding its nature is the first step toward understanding everything else. This question pushes us to the very limits of our knowledge. It forces us to confront the boundary between physics and philosophy. When we ask why, we are seeking a reason, a cause, a purpose. Science is excellent at explaining the how. How space expands, how it's warped by gravity, how it emerged from the Big Bang. But the why teeters on the edge of what we can empirically test. It invites us to speculate, to imagine, to piece together the clues the universe has left for us. It's a grand detective story where the crime scene is the entirety of existence, and the mystery is its own origin. So what is this stuff we call space? In the simplest terms, space is the three-dimensional expanse, in which all objects and events have a relative position and direction. It's the where for everything in the universe. Imagine your bedroom. The space in your room is what allows your bed, your desk, and your chair to exist in different locations. You can measure the distance between them. Now just imagine that room without any walls, ceiling, or floor, stretching out in every direction forever. That's the basic idea of space. It's the ultimate container, the framework that holds every star, planet, galaxy, and dust cloud. For a long time we thought of space as just an empty, passive backdrop. This was the view of Isaac Newton. He saw space as absolute, unchanging, and separate from everything within it. But then, along came a certain patent clerk named Albert Einstein, who completely revolutionized our understanding. He showed us that space is not passive at all. It's a dynamic, active participant in the workings of the universe. It's a thing in its own right, not just the absence of things. It can be bent, stretched, and warped. This was a mind-blowing realization that changed physics forever. Einstein unified space with time, giving us the concept of space-time. He described it as a four-dimensional fabric. Think of it like a giant, stretchy rubber sheet. Let's try to wrap our heads around the sheer scale of space. The numbers are so astronomical, but analogies can help. If our sun were the size of a grapefruit, Earth would be a grain of sand, orbiting about 50 feet away. On this scale, Proxima Centauri, another grapefruit, would be over 2,000 miles away. That's the distance from New York to Los Angeles. And in between, a whole lot of nothing. That's just our immediate cosmic neighborhood. Our galaxy, the Milky Way, contains hundreds of billions of stars. If our solar system fit inside a coffee cup, the Milky Way would be the size of North America. It's an island of stars in a bigger cosmic ocean. The emptiness of space is as staggering as its size, about 5 hydrogen atoms per cubic meter. By contrast, the air you're breathing has about 10 quintillion, a 10 with 18 zeros, times more atoms per cubic meter. So, where did all this space come from? The leading scientific theory is the Big Bang. Now the name is misleading. It wasn't an explosion in space like a bomb going off, it was the explosion of space itself. About 13.8 billion years ago, everything we see in the universe today, all matter, all energy, and all of space, was compressed into an unimaginably hot, dense point smaller than a single atom. We call this a singularity. We don't know what, if anything, came before it. It's the current boundary of our scientific knowledge, the beginning of time and space as we know them. From this single point, the universe began a process of rapid expansion. In the very first fraction of a second, in a period called inflation, space ballooned out at a rate faster than the speed of light. It went from subatomic in size to bigger than a galaxy in an instant. This wasn't matter flying through space, it was the fabric of space itself unfurling at an incredible rate. The idea that space is expanding is honestly one of the strangest and most wonderful in all of science. It's not that galaxies are flying through space like rockets, but that the space between them is actively being created. Let's go back to our raisin bread analogy for a second. The raisins aren't moving through the dough itself is expanding and carrying the raisins with it. This is a crucial distinction. It explains why we can observe galaxies moving away from us faster than the speed of light. Nothing can travel through space faster than light. But space itself can expand at any speed. It's kind of a loophole in Einstein's cosmic speed limit. This expansion isn't just some historical event from the Big Bang, it's happening right now, all around us. The fabric of the universe is stretching every single second. The expansion is, however, quite gentle on small scales. The gravitational pull between the Earth and the Sun is far too strong to be overcome by this cosmic stretch. And hey, the atoms in your body are held together by electromagnetic forces that are vastly stronger still. So, you don't need to worry about expanding along with the universe, but on the vast scales between galaxy clusters, the expansion is the dominant force, relentlessly pushing everything further apart. What's driving this expansion? For a long time, astronomers thought the expansion should be slowing down due to gravity, like a ball thrown into the air that slows down and falls back to Earth. But in 1998, observations of distant supernovae revealed something astonishing. The expansion is accelerating. It's getting faster over time. This was a shocking discovery that actually earned its discoverers a Nobel Prize. To explain this cosmic acceleration, scientists have proposed the existence of a mysterious invisible force that permeates all of space, which they've dubbed dark energy. We don't know what dark energy is, but it appears to make up about 70% of the entire energy content of the universe. It acts as a sort of anti-gravity, pushing space apart. Its existence implies a really strange future for the cosmos. In the far distant future, our galaxy could be left as a lonely island in a vast, empty and dark void. How do we know any of this? We can't go out and grab a piece of space to study in a lab. Instead, we have become cosmic detectives using powerful tools and our own ingenuity to read the clues the universe sends our way. Our primary tool is the telescope. Telescopes are essentially time machines. Because light takes time to travel across the vast distances of space, when we look at a distant galaxy, we are seeing it as it was in the past. The light from the Andromeda galaxy, our nearest major galactic neighbor, took 2.5 million years to reach us. So we see Andromeda as it was 2.5 million years ago. Telescopes like the Hubble, James Webb Space Telescope, allow us to look billions of years into the past, seeing galaxies as they were when the universe was just a fraction of its current age. We don't just look at visible light. Scientists study the entire electromagnetic spectrum, radio waves, microwaves, X-rays, to gamma rays. Each type of light reveals different cosmic processes. For instance, the cosmic microwave background radiation is the faint afterglow of the Big Bang itself. It's a baby picture of the universe when it was only 380,000 years old. By studying the tiny temperature fluctuations in the CMB, cosmologists can learn about the initial conditions of the universe, its age, its composition, and its geometry. It's one of the most powerful pieces of evidence we have for the Big Bang model. Another incredible tool is the study of gravitational waves, first predicted by Einstein a century ago, and first detected directly in 2015. Gravitational waves are ripples in the fabric of space-time itself. They are created by the most violent events in the cosmos: collision of two black holes, collision of two neutron stars. These ripples travel across the universe at the speed of light, carrying information about their cataclysmic origins. Detecting them is like being able to hear the universe, opening up an entirely new sense for exploring the cosmos. In addition to observing, scientists also use powerful computer simulations. They can input the known laws of physics and the initial conditions observed from the CMB into a computer, and let the simulation run for a virtual 13.8 billion years. These simulations can reproduce the formation of the cosmic web, galaxies, and clusters with stunning accuracy. By comparing the results of these simulations to what we actually observe with our telescopes, scientists can test their theories and refine their understanding. It's a powerful combination of observation, theory, and computation that allows us to piece together the cosmic puzzle. For all that we've figured out, the universe still keeps a tight lid on some of its biggest secrets. Perhaps the biggest is dark energy. We can see its effects. The expansion of the universe is accelerating. But we have no idea what dark energy actually is. It makes up about 70% of the universe, meaning we're in the dark about the vast majority of reality. So we return to where we started, looking up at the sky and wondering why space exists. We've journeyed from the simple idea of an empty box to a dynamic, expanding, curving fabric of space-time. We've seen how its existence is tied to the very birth of our universe in the Big Bang, and how its shape is sculpted by the matter within it. We've learned that this vast expanse is not just a stage, but an active participant in the cosmic story. A story still unfolding, filled with profound mysteries like dark matter and dark energy. Understanding all of this changes our perspective on ourselves. The existence of space is what makes our existence possible. The vast emptiness provides the stability for our planet to orbit our star for billions of years, allowing life the time it needed to evolve from single cells into conscious beings who can ponder the cosmos. The laws that govern the expansion and curvature of space are the same laws that hold our feet to the ground and keep our planet tethered to the sun. We are not separate from the universe, looking in from the outside. We are made of stardust, living on a planet held in orbit by the warped fabric of space-time. And our minds are capable of comprehending this grand reality. This cosmic perspective is profoundly humbling. To see Earth as the pale blue dot, a tiny mote of dust suspended in a sunbeam, is to realize the preciousness and fragility of our world. In all this unimaginable vastness, this is our only home. The study of space doesn't make us small, it makes us aware of how special our circumstances are. The universe had to be just right for us to be here. The laws of physics, the properties of space, the initial conditions from the Big Bang, all had to fall within a very narrow range for stars, planets, and life to emerge. Ultimately, the mind-blowing reason space exists is that without it, nothing else could. It is the fundamental condition for everything. And the quest to understand it is one of the noblest and most deeply human things we can do.